Let's take a look at a third example of hypothesis testing. Suppose we collected a random sample of college women's basketball scores at alpha equals 0.05. Is there enough evidence to determine that college women basketball teams have an average score of less than 72? So below we have the scores that we have collected of these various games. So again, we always start out with our hypothesis testing with hypotheses. So we have our null hypothesis in this case. Again, we're looking at something about means, so we're going to have mu, and if there's no difference of 72, then it's going to be equal to 72. Our alternative hypothesis, we're wondering, in this case, is it less than 72? So we're going to have mu is less than 72. So what we notice here is that we are looking at means. We are looking at a one sample. We have an unknown population standard deviation. And this, again, is a one-tailed test. It's a one-tailed test because of our alternative hypotheses. So these, as a reminder from the last video, if we're looking at means of one sample with an unknown population standard deviation, we're going to be using a t-test. So if we go over to our calculator, we turn it on, we go over to stat, we go over to our tests, and we choose the t-test. Now, in this case, I have not given you any of these types of statistics we need. We don't have our sample mean, we don't have our sample standard deviation. Now you could go ahead and calculate those and enter them in, but an easier way is that we're going to go over to this data option. So our data option, we have our mu sub 0 is our null hypothesis, which is 72. Our list is L1. Well, we haven't put anything into L1. So we're going to have to go back and press the stat button and go to edit. And we want to edit our list and put these numbers in. So we'll go ahead and put in 68, 76, 58, 90, 88, 59, 70, 50, and 62. Okay, now if we go back and press stat, we go over to tests, we go down to t-test again. Now our data, it makes sense now to have our data into L1. Our frequency is that every data value just appears once. So we're just going to have 1 appear. Our alternative hypothesis, well, again, our mu sub 0 is 72, and our alternative hypothesis is mu is less than 72, so we're going to choose the less than option. Go down here and we calculate it. And so from here, we see that our test statistic in this case is t is equal to negative 0.6608. And then our p-value is equal to 0.26365. Now notice what we can calculate here. We can calculate the sample mean was 69, our sample standard deviation is 13, and there was 9 data values, right? So you could double check and make sure that you were supposed to have 9 data values. So that's a good way to check this. But notice with our sample mean, we're saying the sample average was 69. We're wondering, is that really sufficient to say that it is truly less than 72 and it wasn't just due to sample error? So when we look at this p-value, it's not extremely small. Right, this doesn't really seem like we should be very convinced that to be as extreme or more extreme is very likely. So there's a little side note here. Something that you can do is press stat, go back over to tests, go down to your t-test option, go down, instead of the calculate option, click draw. And what this is going to do is this is going to help you visualize this shaded in area is the p-value. So if you're looking at this distribution, you're saying that to be as extreme or more extreme is that you're going to land in this shaded region. The shaded region is pretty big, so it doesn't seem like we should be that surprised to get a sample mean of 69 when we're testing this against a population mean of 72. So now we can write down our conclusion. And so our conclusion in this case is that since our p-value is equal to 0.26365, which is very clearly larger than 0.05, which is our alpha, we do not reject the null hypothesis. We do not reject the null hypothesis. We do not have sufficient information to believe the average score is less than 72. Right, we have some evidence to believe that the mean is less than 72, right? Our sample was 69, so it's not like completely unheard of, but it's just not enough. We don't have enough to really say that it's not due to random chance, that it is something special going on. So again, another example, just making sure that we can tell the difference of when we should use our stats or versus entering our data into L1.